In this lesson, we'll do few more questions for better understanding of arithmetic series. First question is, how many terms of series -7, -4, -1 and so on amount to 114? In this series, the first term is -7. So, for question 1, A is representing the first term and its value is equal to -7. The common difference D can be calculated by subtracting first term from the second term. So this is -4 minus first term, which is -7. This will be equal to -4 plus 7 is equal to 3. So the common difference D is equal to +3, and the sum of series is given that it's 114. Sn is also given, sum of n terms, that is 114. What we are required to find is the number of terms, so n is required. If we look at A, D, Sn and n, the formula that comes in mind for arithmetic series is Sn is equal to n by 2 times 2a plus n minus 1 into d. Using formula for arithmetic series, for arithmetic series, that formula is Sn is equal to n by 2 times 2a plus n minus 1 into d. If we substitute the values for this formula, Sn is given, that's 114. 114 is equal to n by 2, which we need to calculate. 2a, a here is -7 plus n minus 1 into d, d is +3. So let's solve this. This will give us 114 equal to n by 2 times -14 plus 3n minus 3. If we multiply 2 on both sides, that's what we get is 114 times 2 is equal to n times -14 plus 3n minus 3. So here we get 228. 228 is equal to n times 3n minus 17. And if we multiply n inside, this will be 228 equal to 3n squared minus 17n. And by moving 228 on other side, this will give quadratic equation 3n squared minus 17n minus 228 is equal to 0. For n, we will be solving quadratic equation, and we can either factorize or we can use quadratic formula. Let's use quadratic formula. Coefficient of n square will be a, which is 3. B is coefficient of n, which is -17, and c is equal to -228. Using quadratic formula, here we get n equal to minus b plus minus b squared minus 4ac. That's called quadratic formula for solution of quadratic equations over 2a. Now if we substitute the values, we get minus 17 plus minus, and minus 17 square minus 4 times a, which is 3, times c, which is minus 228, divided by 2a, 2 times 3. So this will give us 17 plus minus 289 plus 289, and plus this will become 2736 divided by 6, and if we add up, this becomes 17 plus minus 3025 divided by 6, and here if we take square root of 3025, that will give us 17 plus minus 55 over 6. As n is number of terms, it can never be negative. Therefore, n is equal to 17 plus 55 over 6. That's one value. The other value is 17 minus 55 over 6. So if we only consider the positive value, that would be 72 over 6, which is equal to 12. So in this series, 114 is sum of 12 terms, and the other one is absurd because n is negative and number of terms cannot be negative. So the required number of terms is 12. Therefore, there are 12 terms whose sum is equal to 114 in this series. Now, question number 2. For question number 2, we have summed the series 1 plus 4 minus 7 plus 10 plus 13 minus 16. So let's write down the series here. Question number 2, given series is 1 plus 4 minus 7 plus 10 plus 13 minus 16 plus 19 plus 22 minus 25 plus so on, continuing this way up to 3n terms. As the total number of terms in the series is 3n, therefore we are going to split this series into 3 components. So we take a look on this triplet here, and then we take this triplet here, 3 terms in each one of them, so that we can break each triplet into 3 different series like this. So this will be equal to the first one from each triplet, 1 plus 10 plus 19 plus so on. If we continue up to n terms, then we take the second one, that would be second number from each triplet, 4 plus second number from second triplet will be 13, and then would be 22 plus so on, and these will be n terms, and if we take negative common from the third number of each triplet. This will be 7 plus 16 plus 25 plus so on up to n terms. So you can see that how we have broken 3n terms into 3 different series, each consisting of n terms, and then we will apply simply the formula for arithmetic series using Sn equal to n by 2 into 2a plus n minus 1 into d for each of the series. So this will become n by 2 into 2a. A here is 1 for the first one, plus n minus 1 into d, which is 9, because 9 is the difference between successive terms, plus n by 2 again into 2 times 4, because the first term in the second series is 4, plus n minus 1 into 9 again, because this series has 9 as common difference as well, minus n by 2 into 2 times 7 plus n minus 1 into d, which is 9 again. So this way we can sum 3 different series, each consisting of n terms. And now if we take n by 2 common from all 3 of them, and what we are left inside is 2 times 1 is 2 plus 9n minus 9. N by 2 has gone common, plus 8 plus 9n minus 9. And this time minus is outside, so inside signs will change. This will be minus 14 minus 9n plus 9, and this way we can cancel out this minus 9 and plus 9. These will get cancelled, and now what we have is here n by 2 into 9n minus 13. 9n minus 13, and if we write this down in the form of 9n minus 13 divided by 2, so that would be the answer. That will be sum of the 3n terms for the given series. Now the question number 3 that is given here is that we are going to suppose find 5 numbers in AP, mean in arithmetic progression, whose sum is 25 and sum of whose squares is 135. If we are going to consider 5 numbers, remember this, if we consider odd numbers in AP, mean in arithmetic progression, the middle number we take is A, and we take the next number A plus D and the preceding number as A minus D. And here you can see that these 3 numbers are in AP and common difference is D. So A minus D, if you add D to this, that next will be A. If you add D to this, this will become A plus D. Whenever we are going to consider odd numbers, middle number will be A, and then you can add D and subtract D. And if you want 5 numbers, you can add one more D. This will become A plus 2D, and here it will become A minus 2D. You can see this, that the common difference is D in this case. But if you were to take even numbers, then a cannot be taken as middle number, and in that case we will have 2d as a difference, and a minus d and a plus d will be the two middle numbers. Anyway, we'll discuss that at the end of this question. For now, these are 5 numbers in AP. B, 5 numbers in AP such that their sum is given that this is 25. So a minus 2d plus a minus d plus a plus d and a plus 2d. Add all of them up and the sum is equal to 25. Of course, this plus d and 2d and minus 2d and plus d and minus d will cancel out. This will give us 5a is equal to 25, means if we divide 5 on both sides, a will be equal to 5. So this is how we get the value for a. And now there is another condition, that sum of squares is equal to 135. Also given that sum of squares is 135. That's given. So if that is the case, then what were the numbers? A minus 2d square plus a minus d square plus third number a square plus a plus d square plus a plus 2d square is equal to 135. If we expand these perfect squares, this will give us a square minus 4ad plus 4d square plus a square minus 2ad plus d square plus a square plus 2ad plus d square, and the last expansion would be a square plus 4ad plus 4d square equal to 135. This minus 4ad and plus 4ad are gone, minus 2ad and plus 2ad are gone, and if we add up a square plus a square plus a square, these are 5a square, so this will be 5a square, and then 4d square plus d square plus d square and plus 4d square will become 10d square is equal to 135. If we divide 5 on both sides, divide by 5, this will give us a square plus 2d square is equal to 135 divided by 5. That will give us 27. And now since a was equal to 5, we already calculated that. Since a was equal to 5, therefore we get 5 square plus 2d square is equal to 27. This means 2d square is equal to 27 minus 25. This will give us 2d square is equal to 2, or d square is equal to 1. Means d is equal to plus minus 1. If d is plus 1, if d is equal to plus 1, then what are those numbers? A minus 2d, a minus d, a a plus d and a plus 2d are the numbers 5 minus 2, 5 minus 1, 5, 5 plus 1, and 5 plus 2. Because if we substitute a is equal to 5 and d is equal to 1, this is what we get. So this would be 3, 4, 5, 6, and 7. If you take their sum, that should be 25, and if you take sum of their squares, that would be 135. If d was equal to minus 1, then these numbers a minus 2d, a minus d, a plus d, and a plus 2d would be like this: 5 plus 2, 5 plus 1, 5, 5 minus 1, and 5 minus 2. Then these numbers would be 7, 6, 5, 4, and 3. But the numbers will still remain the same, and these are the numbers whose sum is equal to 25 and sum of whose squares is 135. Before we end this lesson, we will emphasize over one thing, and let's make it a special note. If numbers in AP to be considered or to be assumed are even, then there is no middle number. Then what we do, there are two middle numbers. What we do, a minus d and a plus d. And remember, the common difference between them is 2d. If you subtract a minus d from a plus d, the answer is 2d. Therefore, the next number would be a plus 3d, and the number before this would be a minus 3d. This is very important point, that whenever you are assuming even numbers in AP, there is no middle number. So the two middle numbers would be a minus d and a plus d. Therefore, the difference would be 2d, and if you want 4 numbers or 6 numbers or 8 numbers, continue to add and subtract 2d. But if you are wanting to assume odd numbers, then a is the middle number and the common difference would be d.